Hello, everyone. This is the last talk from the Quality Gems track at the TestCon Europe Conference 2022. I'm Christina. It was my pleasure to be your host at this track for the last 2 days, and we're closing with an interview. Let's wake up a little bit. Not only an interview, but consider this one big Q&A session. Write your questions in the Q&A section at any time. We'll take them with priority. And the talk is about legacy code. Testing legacy code and what to do when it seems untestable. And this is how most of the legacy code look to us. But we have Christopher Miller with us, and he will tell us his approach. That is not very, very inspiring, actually. So, Chris, welcome. Thank you for
Thank you.
being with us. Tell us a little bit about yourself. Who are you and why do you want to talk about legacy code? Nobody wants to touch it and you want to talk about it.
I like legacy code, especially after I've written the tests. So for me, I started my life with computers in 1983. ZX Spectrum, brought home in a box, soldering iron. Me and my dad sat there, soldered these things together, and I thought that was the fun. And then he plugged it into the telly, and even more things started happening. And I remember that feeling then, even at the age of 3, of this thing can do amazing things. And I also remember he said to me that one day these things are going to replace my job, so you might as well learn about them now. 20 years later, the company that he worked for closed their doors due to being completely automated out of the role. So he was absolutely spot on. Um, that's what started my life with computers. From there, all through school, interested in computers. At the age of 11, was published in Sinclair magazine with one of those massive long lists of source code that everybody had to type in, and that was published at the age of 11. 16, took a placement with NatWest Bank here in the UK to help roll out Windows NT across the bank, and that was the day I knew that there was no alternative. IT was the field I wanted, and went from there. Did BTEC National in computer studies, where I was taught everything there was to know about Windows XP. Then they released Windows 98 on the last week of my course, so everything I just learned was completely irrelevant. But I went out of there, set up the first web development company in Staffordshire, here in the UK, and back when web development was primarily make text look pretty, and also rolling around on the floor running cables when cables were a thing with networks. Ended up ill for a short time, and which took me out of the industry. As I started to apply to go back into the industry, I found that my skills were too far out of date, and I actually went to School of Code, so a boot camp training provider here in the UK, where teaches people full stack development from beginning to end in 16 weeks, and then supports people into work. Went from there to 2 further jobs in the industry. One with a company that showed me lots of things not to do, and one with a company that showed me lots of things to do. And then about a year ago, I actually rejoined School of Code as one of their tutors, and have since gone to head of IT and development here at School of Code. So my journey went full circle somewhere in the middle, with 22 years of experience working in the industry, on code bases from simple brand new sites through to full blown legacy apps that are 10 years old, and reworking the testing and quality for those.
So, how often have you actually dealt with legacy code and what's your uh, favorite or least favorite example? It's not sure how
Okay.
to put it.
So most of my job is dealing with what I would consider legacy code. So looking at code that I haven't necessarily written, and code that may not be the easiest to understand. So that's part of what I would define as legacy. If the code is easy to understand, then it doesn't matter if it's 20 years old or 10 minutes old. It's not a legacy application that you have to consider every single step. My most favorite example is a code base that I worked on where when I started working on that code base, there was 0 tests. And when I finished working on that code base 3 years later, there was somewhere in the region of 20,000 tests across the 5 different repos. Those tests ensured that the code was of good quality, that the code was meeting the requirements for the customer, and they were also running in 12 minutes across all of the apps. Simply because I took the time to think about the tests that I was writing, and starting just by writing one and then another one and then another one. Over time, that testing suite grew. Probably my least favorite example is a code base where I was working with one particular controller. Now, I am fairly sure this was 10,000 lines long, but it was pretty close to that, even if it wasn't. And it was doing everything. It actually became known as the God controller. You don't touch it because it breaks. And that was my least favorite example until I started to unpick it and started to unwind some of the logic that was going on in there. And I started just by adding in a test that followed the best path through. So everything that was good in that scenario. So the user was authenticated and this had happened and that had happened. And then the right answer came out of the other end. And I'd got that test in. Over the space of about a week, I added in further tests, and over that week, I started to unpick that controller, and we actually found in that controller that one loop was being repeated 3 times for no obvious reason. There was no logic to why. It was just that people hadn't got the logic being tested and hadn't got that loop understood as to why it could have been done once.
As if one loop is not enough. With probably all of us have part of their applications where nobody wants to touch it because it breaks, or it breaks even when nobody touches it. What?
Absolutely. You saying that reminds me of a code base that's owned by a rather large gaming company. The code base is Oblivion. It's a game that was out a fair few years ago, part of the Elder Scrolls series. In that code base, there's a picture. That picture is a picture of a coconut. The file doesn't appear to be referenced anywhere in the code base. And it's definitely not being shown in the game. But if you delete it, the game won't compile. Why?
You know the meme now of John Travolta. Why? Nobody knows, probably.
No. They've tried many times to remove this and find out why, and nobody can work it out. It seems like it's just a phantom file that's needed.
Then, now it will take me a while to recover after this story, but what's the difference between code now and what you consider legacy code?
So, code now is code that is easy to understand whoever's looking at it. So it's considering how you've broken up the code. So have you got things that make sense together in the same place? Have you got things that don't make sense in a different place? Have you considered naming conventions? Example, what if I said to you function A plus B, what's that going to tell you about anything? Well, precisely nothing. Whereas if I said function add 2 numbers, number 1, number 2, well, now I haven't changed the code. I've just changed the way that it's phrased. So legacy is partly about the way that the code is written, partly about how the code is architected, and primarily not about how old the code base is. I've seen legacy code that's less than 6 months old that I've even written myself. I can go back to my own code and go, that's terrible. And that could be yesterday's code. I will always take an approach of clean it up as I go along. So if I see something that could be better, I'll clean it there and then. And that's whilst I'm in that particular file. And it's kind of like the Boy Scout idea of leave everything better than when you started. And so I think that's the difference between non-legacy and legacy code for me is the consideration you put into the code and the consideration you put into the next person reading the code. So the next person can be you. And so many times that happens, you can look back even at your own code and go, what the hell is that? But you can also look back and go, oh yeah, that makes sense because it's nice, clear, simple code. And we seem to have this idea in the industry that simple means bad, but actually it doesn't. For me, simple means good. It means easy for people to understand.
There were very famous more memes about comments in the code and please future me, don't hate me. I've made this on purpose. I don't have time to explain right now, right? Um, Definitely, we need to be taking care of everyone after us, but also ourselves because we could have to be fixing this code in 2-3 weeks even, and it
Yeah.
will cost us late night or missing a family dinner. What are the risks with legacy code tests then?
So the risk is primarily not knowing what the code is doing. So we may have an idea of what the code is doing, but we may not know all of the intricacies of what's happening in there. And the risk of testing the legacy code is that you miss some of those requirements. So when you're beginning to write the test suite for code, well, you consider all of the pathways. If you've only got one or two pathways, then it's fairly easy to see the route through the function. But what if it's got 20, 30, 40 pathways through that function? For every pathway you have a positive and a negative answer at least. So you can guarantee for every pathway, you've got at least 2 tests, probably more. And the more complex it is, the more chance there is of you missing something. So the biggest risk is missing requirements that you don't necessarily understand at the time. A lot of companies will clean up boards and get rid of old tickets that have been attached to work. Generally, I try not to do that. I'll just archive them, because if they're archived, I can go back and I can go, right, when this was written in 2019, the request from the company was that we did this. And I can do that because of naming conventions in the commits. So the commits will always use the key for the ticket. By going back and looking at that, I can minimize that risk. Does the risk go away completely? Of course not. We're human, we make mistakes, and until we come up with an AI that can code perfectly and know exactly what we meant even when we don't tell it, I don't think we're going to have a problem with that. So humans are prone to making mistakes, but if we have more information in front of us at the time, the less risk we take with every test that we write.
You remind me of something. How would you rate traceability in helping with dealing with legacy code then?
So traceability in terms of the code base, or traceability in terms of the requirements. So
Both.
So
Both.
in the code base, traceability is absolutely essential. If you can't work out how it's going from A to B, it might go from A to B via X, Y, and Z. But if you can see that pathway, it's vitally important to map that out. And I have previously, where I've gone onto a code base, taken a day or two just to literally sit there and map out how functions link to other functions. And I'll sit there with a piece of paper and I'll end up with this spider's web at the end. But the idea is that that spider's web gets less and less and less complicated. In terms of traceability of requirements, I think we actually do ourselves a disservice with not keeping those requirements around. There are occasions where I've been working on a code base and bugs have come back to me 2 years later on something, where this isn't doing what we expect it to do. And you go, but actually what we agreed at the time was this. And I suppose that plays into the idea of tests. So tests, if you write them in the right way, actually become a contract. So you can create a set of tests that match up to the requirements you were given. If you can then trace back in your repo to that ticket, you can go, well, your requirements were A, B, C, and D. and my tests prove A, B, C, and D. So actually, the contract we had at the time was met. What we're talking through now is a change to the process, which is fine, but it means that it's no longer a bug, it's a feature. And it makes it very, very much easier to have the conversation around the difference between a bug and a change.
Speaking of what benefits in writing tests of legacy code, what else besides it? They are actually the contract between us and the users and the development team or anyone involved.
So, one of the talks that I'm doing regularly at the moment is called Clean, Concise, Collaborative Code. It's focused on asking questions about your own code. And I finished that off with two key questions. Question one is if a non-developer can a non-developer understand what your code is doing, even if they don't understand how? So the tests play into making that happen. And why would you want a non-developer to understand your code? Well, if they can understand it, then any developer can. And the second question is, if you were hit by a bus tomorrow, could somebody pick up where you left off? Commonly called the bus factor. And most of the time, the answer is actually no, we can't. But the closer we get to that, the better it is for everybody. And the playoff between that is how much do you consider the bus factor in how you're planning something. So for me, I'll sit there and I will literally write a plan of where I'm going with a feature. And I'll write a plan of what tests I expect it to need. I'll write a plan of what functions I expect to write. Do I give line by line what the code's going to do? No, because my plan tied with the original requirements means that you've got a clear idea of where I was going. Tying those together gives you the benefit of A, your tests become clearer, because if your plan's clear enough, your tests are actually written by the plan and the requirements. Because what I've found is the more tests I put in place, the more customers actually think about, well, actually, they're going to want to write tests on this, so I need to start thinking about what I'm going to do and what happens if. So that those what ifs start to get answered by customers a lot more regularly when I've started to put tests in place, even on legacy code. And sometimes I'll just start by writing the first test on the new bit that I'm doing, because then they start to see the value on new code. And often I've actually had the scenario where people have come to me and said, would you mind spending the next 2 weeks writing tests on some of the older code? No, I don't mind doing that at all.
That's a change in attitude. Before we proceed with risks and common problems on legacy code testing, here's a very interesting question we have from Pastor. At work, I had a discussion with our test lead on readability versus reliability. And his view is that if it works, it's all good. Just add some documentation. Also, reusability messes with readability, according to him. What are your views with your experience in legacy testing?
So it's two trains of thought, and neither are actually wrong. And the the first train of thought is readability is about having the least amount of information in your mind at any given time. So if you've got simple functions like get number, get string, it's very, very obvious what it's doing. Do you need to know the ins and outs of how it's doing it at that precise moment? Probably not. If you do, let the IDE help you by clicking on it, and it will take you to that function to show you. Um, so you've got the idea that readability is built around making the least information in your brain at any given time for a pathway. You've also got the readability in terms of isolating code to the right places. So things like design patterns such as MVC, having models, views, and controllers makes it easy to understand what's happening. Layer on that services, and you're taking more out of the controller. Layer on that repository pattern, you're taking yet more out of the service. So your code becomes smaller and smaller in each given file. So yes, you end up with more files, but actually you end up with code that's more testable. I find for me that if a function does one thing and does it well, then my code is much easier to test than one function that's nice and clearly laid out and goes through every step, because I have to consider so much more when I'm testing that. Whereas I can take one little bit, pull it out, and test it in isolation. So the idea of adding documentation, for me, documentation is more around adding something that will help rather than hinder the people reading your code. So by that, I mean, if I need to write a document that explains what my code's doing, then I would rather take the time to refactor that code and to make that code easier to understand. So a really simplified example, if I have a set of user authentication, and if I'm admin, one thing happens. If I'm a user, another thing happens. If I'm a guest, another thing happens. In code, we could go, if admin, do this. Else if user, do this. Else if guest, do this. Else if, do this. Else if, do this. And that is readable in one sense, because it's clear that it's if, else, if, else, if, else. What I often find is that if I write a switch statement instead of that, which is, it's a really contrived example to make the point, but the switch statement becomes easier to understand, because instead of writing if else, if else, if else, you go, hey, here's the thing I want you to look at, tell me what to do, rather than saying, what I am this. Am I this? No. Am I this? No. Am I this? No. It's, I'm this. What am I doing? So documentation in that sense would be a case of look at the code, extract out the complexity there, and then the documentation shouldn't need to tell you what's happening. Maybe it just needs to tell you why. So an example would be, in one function I had a number that I needed to convert from an integer in one part to a string in another and to a float in another. Now that sounds like a really stupid thing to do, and honestly it probably was. But if I had to put some documentation at the top of this to explain why, because of where that particular section of the function was routing. So it needed an integer for one type of calculation, a float for another type, and a string for the front end to represent it. And those three, I explained why it was happening, but because the code was clear, it was using number convert to, and then you just passed in, and it made it very clear reading the code what was happening. The two side by side, readability and reliability, honestly, just have the conversation about the the exact ins and outs of that particular function. And reliability can actually be improved by readability, and readability can be improved by reliability. The two aren't mutually exclusive. There might be a middle ground that works best for that particular team.
Thank you. Thank you for answering this question. Then, back to testing legacy code, common problems that you've encountered.
I think the most common problem that I encounter is starting from zero. So no tests at all. And this is a problem in the sense that nobody has yet considered this. So they haven't considered the impact that testing makes on the code. So again, using that 10,000 line controller as an example, because nobody had considered testing, it was perfectly fine for that controller to just grow and grow and grow. Whereas when they did make the decision to go down the route of testing, it meant that that was now 10 times more complicated to test. Was it impossible? No, there was just a heck of a lot that you had to do to make it work. So, for example, you had to create your request to look at it. You had to create your database responses, and you had to somehow make sure that that was happening. And then you had to make sure that the service was mocked because it was making changes. And then you had to make sure that something else was mocked because it was making changes. And there was so many things that you were mocking. By the end of the first set of tests, there wasn't a huge amount being tested, but there was enough for me to start pulling on that very first little thread and start pulling it through. And by the end of it, The plate of spaghetti turned from this really horrible mess to perfectly laid out lines that were clear. Did any of them cross over? Of course they did. It happens in code. It's almost impossible to have perfectly linear code in any scenario. But the branching can be a lot cleaner and a lot easier to follow. Um, Another common problem is customers not understanding the value of it. So not understanding, well, it's already worked forever. Why would I want to add some tests? Absence of evidence is not evidence of absence. So just because something hasn't happened yet doesn't mean it won't. The other the other part to that, of course, is that the tests do take time to write, and sometimes those first few times it's down to talking to the customer, to explaining that my estimates may be slightly longer than previous people that you've worked with, but what you're getting is this extra value, and showing the value of the tests. I've even done it with one customer where I've gone, do you know what? Let me prove the value of tests. I won't charge you for the time that I'm writing these tests. And I showed them by writing the tests and then showed them the value that those tests added because it actually caught bugs that I wouldn't have seen otherwise.
That might also have changed their attitude and the way they consider, do they need testing at all, or let's start with testing probably.
Yeah, and
Then
that's that's one of the things that often happens with customers. Why do I need testing? Why do I need testing? Until you start telling them, it means it'll cost them less in the end. Take it down to money if you have to. It will cost you less for me to write a test now that proves this does what I say it does than it would for me to solve a bug later when I discover that it doesn't do that.
yeah, it's difficult to, and even in the previous talk, it's difficult to think what will happen in 1 year or 2 years. Very few of us really want to hear about it because it's something
Yeah.
potential. It might happen, might not happen. It will happen. We testers know that that the issue will happen, and we will have to be untangling the spaghetti code to
Yeah.
fix it. How would you approach that first test? What will be the first test that you will write when you start working with legacy code?
So the first test I write is always on the code that I'm using at the time. So if my first task is to add a new feature, then actually my first tests are going to be on that new feature. Now that may touch other areas. That means I'm writing some tests for the older code. But if the first task is we've got this bug, please fix it, well then my answer to bug finding in that scenario is let me write the test for this section. So those tests might be very, very specific. It might be that if you enter in this exact word in this text field after you've entered this in this field, then so and so happens. I'll follow it through, and I will make sure that I will replicate that bug in the test so that I can see which parts of the code are being touched. Now, my language of choice is PHP, so I will use Xdebug to help with that, which will show me the values of variables at the time I'm running. But the tests could do that in any language. They can show me the value of variables at any given point if I choose to freeze a function in at that point to identify what's happening. Um, if it's neither of those and it's just we want you on maintenance and to keep the code base up and running, well, then my first test will be pick some of the easier areas and start adding in those. So those nice simple tests that make themselves evident, like I click on this button, I go to this page, that's a very easy test to write. So adding that test in means that if I go and change something elsewhere, I now can be confident that that's not going to break. And I think that's where it's a case of build it up as you go along, and that whole Boy Scout idea, the idea of leave it cleaner than when you started.
Then does it mean that you kind of make a difference between high test coverage and good test coverage?
Yeah, so high test coverage means there's more of the code base called in the test. But calling code is not the same as checking it's doing what you want. I can call that 10,000 line controller and it will say that that's covered. But I can assert that true is true and it'll do absolutely nothing. Good test coverage would be, is the code actually being tested? So a common scenario that I've seen with badly written tests is that at the end of it, all you're doing is testing your ability to mock things. So I've had it where I've mocked a database call and then I've gone, does my function return what I just told it to return? Well, surprisingly enough, yes, it does. Whereas testing the output from the function if it's making a change, that's more useful. So mock the database call and test the one above it. Do I need to know that my SQL or Postgres or any other database system returns what's in the database? Well, no, because that's not mine to test. But what I do need to know is that what I do with that data works.
Yeah, we need to be careful with aiming for numbers in comparison
Yep.
to aiming for confidence.
Yep.
These are two
Absolutely.
different things.
And that's the key thing, the confidence in the code. And it's not just your confidence as a developer, it's the confidence of the customer at the next stage. They can gain confidence in the code base by having more and more. And I will often give customers the ability on dev environments to run the tests themselves. Hey, go click the button that says run the test suite. I don't care if it gives them a red cross. I'd rather them tell me, hey, when I ran this test suite, test number 23 failed. Okay, cool. We've identified a bug. Let's go see what it is.
This brings us to actually one of the questions from the audience. It's from Tobias, and and also back to the topic about business and how do you convince them that tests are needed? How do you make them pay for testing?
So, are tests needed for code to work? No, they're not. Code works without tests. What you are convincing them is not that tests are needed, but that tests increase the quality of your code. Now, some businesses will not care about code quality. They want it yesterday and they want to pay the least amount of money possible. Some businesses will really care and will just go, you're the expert, do what you want. Just bill me at the end of it. The ones in the middle are the ones where you've got the ability to start talking to them about the value. And customers will always think value first. So, what am I getting for the additional money that I'm paying? I will talk customers through. At the moment, we have a set of code. We understand that it works in most scenarios. We know that it's not perfect and we know that we have bugs because no code base is perfect. What we don't know is how big is the problem? How much work do we need to put in to make this the next step up? How much work do we need to put in to clean this up and make it so that users are even more happy than they already are? Because if they're going to pay a developer, then they have users that are using this somewhere. Um, so how can we add that? And I will start talking through the idea that we've got three options. Either you can pay for somebody to do a manual set of tests every time I finish developing. Now, let's say that it will take 2 days for that to happen, and I'm doing 2 sprints a month. So you're paying somebody for 4 days a month, every month, to repeat the same task. Oh, and the more features we add, the bigger this gets, the more time you're paying for. 12 months from now, it might be 5 days a month. 24 months, it might be 2 weeks a month. Over time, that mounts up. But what we have the option of is I can write some tests that will help us to show that this code base does what we think it does. Now, this is going to take time and this is going to take money, and it will probably cost you 4 days of your time for me to write the test for this section. But you don't need to pay me 4 days next time for the same tests. And yes, the testing grows, but you're not paying for somebody to do that new testing every time in the same way as you would manual testing. So I'll give them the the pros and cons of manual testing and the pros and cons of automated testing. And often customers will talk about it and they'll go, okay, why don't we go for something in the middle? And often they will suggest to me the method that I want to do, which is let's write tests for the bit we're doing. And they'll go, okay, let's pay somebody for a bit to do the manual testing. And as you're touching stuff and you're cleaning it up, their job gets smaller, the tests get bigger, and eventually they cross over. At the point they cross over, do we need this manual testing anymore? Not always. Sometimes you'll need manual testing, and I like to call that user acceptance testing. So the idea of it's not now about does this work, it's now about do my users like how it works? And that comes in at the end of each sprint. It comes in even within the sprint. Sometimes I will give users a very small section and go, can you just tell me that that works like you want it to? Sometimes it's daft things like, can I have that button you put on the right over on the left? Of course you can. I'd rather do that now than as a bug at 3 o'clock in the morning on a Sunday.
Nobody wants that. And we've all been there. All right. So, untangling legacy code, we need to clean it, we need to refactor it. We've started with writing some tests to bring a little bit more confidence into the work. When do we actually start refactoring? When do we feel confident enough to do the refactoring?
When the test says that I know what that code's doing. Literally as simple as that. So if I have a function that is complicated, I won't refactor all of that in one go. I'll refactor that piece by piece by piece. So if I've got one route through that I can see is a nice easy one to pull out of that function, then I'll create a test that uses the original function. Then I'll refactor it with the test that I would need for the refactor. So I'll always write the test first, TDD, test-driven development. Write the test first for what we already have, write the test for what we're going to have, then put in the code that I've changed. Now, what I expect to see is that the red cross goes on the original code and the green tick goes on the new test. Because now my code is working, it's just in a different place. And sometimes that's all refactoring is. Taking the exact block of code, copying it somewhere else, and calling it something different. um, Other things that you can refactor without needing a test. Does it matter if a variable is called A or person's name? Does it make any difference to the functionality of the code? No. So that is a safe thing to refactor so long as it's not used elsewhere. So long as it's not a global variable or a variable that's passed around. If it's an isolated variable in a function, the simplest of refactors that can make the code infinitely more readable is just rename it. Make it something that's easier to understand in the context.
Yeah, something that we often forget about refactoring is that it should not change the behavior of your feature. It should make the code better, more
Yeah,
readable, more reliable, easier to troubleshoot, easier to find and fix issues, but it should not change the functionality. This is
absolutely.
and this is what tests are there to confirm that our refactoring will not change the behavior of the code.
Absolutely. And that can also be non-automated tests. That can be a user's testing scenario. So long as the tests are reliable and repeatable, it doesn't actually matter what form that test takes. So long as we know that that bit is being tested and covered with the tests that we're using.
We're used to anyone testing the code, but who should write the test then?
Literally everybody. So junior developers can write some brilliant tests in ways that you may not even have thought of. And they'll look for things that a senior developer won't. Because if you think of experience, as a senior developer, we've got more time that we've spent doing things and more time that we've spent looking at code. So we actually have a breadth of experience to rely on. Juniors don't. And actually is a good thing, because juniors will read code and just test what's there. We'll read code as seniors and test what we think's there, or at least I do. I don't know about anybody else. Um, Also, believe it or not, the person writing the requirements is actually writing tests for you. So if you have requirements that are clear enough, copy your requirements, put them in your test file. Now you've got the titles of your tests, and you've also got what your tests need to be testing. And the cleaner those requirements are, the better your testing experience, the better that conversation at the end of the sprint when you've got those bugs that we always get at the end of a sprint. I don't know a single developer that doesn't have bugs at the end of a sprint.
I know some that think they don't have.
Oh yeah, yeah. Usually ones that haven't tested it.
Amazing talk. Ladies and gentlemen, and Chris, I have one more question before our formal Q&A section, and I invite all of you to ask your questions. We will have a couple of minutes. That's the last session for the Quality Gems track. So please ask. We have Chris Miller right now for us to share his amazing experience, which is obvious. My last question. Was there a time that you've encountered something genuinely untestable?
No, there is nothing that's untestable. I might not know how to do it. I may not have somebody on my team that knows how to do it, but everything can be tested. It's just how complex is that test? So genuinely untestable is a concept that we teach ourselves because we don't want to put the work into trying to work out how to do it. Take those massive controllers. I had some tests that were huge and really complex at the start, but then as I started unraveling it, those tests got simpler and simpler. Now, yes, it meant I wrote more code to start with that I then threw away, but it gave me the confidence as I was refactoring to do that. I remember one in particular where somebody came to me with a complex function. This function was doing tons of different tons of different calculations to get to an end result for a number that they needed for their system. And I looked at this and I wrote the tests around this, and it was going through 30 or 40 steps to get there. And at the end, I started to see a pattern that was appearing in this code. So actually, I went through this and I broke it down, and I looked at the function and I thought, hold on, I could throw away most of these steps because all you're doing is putting the number back to where it started halfway through. So I could chuck away the first half, and then I took the second half and I started looking at it and I said, well, all you end up doing here is actually dividing by 0.3. So I managed to chuck away 29 steps in that process just by having the tests, and I proved that it worked by feeding it data, and it came out with the right answer at the other end. So even when I thought it was a massively complex set of functions to test, I actually found by writing those tests that I could make the code base more efficient anyway.
And that's the power of testing.
Absolutely.
It raises the right questions sooner or later, better sooner than later. But things are always cleaner after some testing is done, whatever sort and or part or level of it. And
Absolutely.
I personally want to just jump and take some software and start writing tests right now. This was very inspiring, very encouraging. Nothing can be, or anything can be tested. Just be patient and
Yep.
vigilant and never give up and just start cleaning up any mess that we've touched. It's just a challenge.
Absolutely. Clean the camp on your way out.
Thank you, Chris. Thank you, Christopher Miller, so much. Thank you, everyone, for being with us yesterday and today on the Quality Gems track. Every talk was a real gem. It was so inspiring, at least for me. I hope it was for you. And we'll meet somewhere around. Follow Chris. I'm sure you're somewhere on LinkedIn or Twitter.
Yeah,
Share.
you'll find me on most socials if you search for CC Miller 2018.
Follow him. He has a lot to share with, and there's a lot to learn from you. Thank you very much for this talk. It was amazing. Thank you, everyone. Have a great day.